So if you haven't listened to either the force diagrams or the terminal velocity, you may want to do that first. So we talked about velocity time graphs earlier, okay? And the ones that I showed you for the actual math were straight lines because that makes the math easy, okay? And so anytime they're asking you to do math on a velocity time graph, you'll usually get something that looks like this, all right? But in reality, when we look at a velocity time graph of, let's say, an airplane taking off on the runway, it doesn't look straight. Instead, it looks like this, all right? So this is your velocity in meters per second, and this is your time in seconds, right? And so the idea is that they'll say, explain the shape of the graph using ideas about forces or explain why this is happening. And so the idea for this is the same thing as the idea of terminal velocity in that you need to think about where are the forces balanced, what are the forces that are acting, and where are they unbalanced and to what degree. So let's take at the very beginning, okay? So at the very beginning here, okay, the object is not moving, right? Its velocity is 0, and it begins to accelerate. And so that's going to be due to a motor force or the engine force, if you're talking about an object like an airplane. This graph could also be a representation of terminal velocity as well. When you drop an object, this is what it looks like, okay? And so this is the motor force or engine force if you're talking about something that has a motor, a car, a train, an airplane. If it's not, then if you're looking at something that's terminal velocity, then this would be its weight. This is the unbalanced, this is the force, the main force that is acting, okay? But then the speed starts to increase. And as the speed starts to increase, then there's another force that comes into play. And so in this area of the curve, this whole area of the curve, the idea is that you are getting drag or air resistance, whichever you want to call it. The two terms are interchangeable. All right. So the idea is that the drag or the air resistance is increasing, and it's increasing because the speed is increasing. Yeah. So, and it isn't until, say, it levels off here, okay? The idea is that now you have a constant velocity. So this is a constant velocity. And the reason that you have the constant velocity is because now the motor force or the engine force or the weight equals the drag or the air resistance. Okay, so this is a constant velocity that's happening. So the forces are balanced. And if the forces are balanced, this should sound familiar, means that there is no acceleration happening. Okay, now there are things you can do to change that. For example, if you were to pull a parachute, all right, on something that's falling, then that is actually going to increase the drag, right? And so you would get a deceleration. All right, you would actually get a decrease in speed. But as the speed decreases, right, as you get this decrease in speed, let me draw it again down here. Right, so if you were to, something jumps out of an airplane, right, the idea is this is your velocity, this is your time. At the point where they pull the parachute, okay, they've reached a terminal velocity, right, they've reached a constant velocity here, but then when the parachute is opened, you're going to increase the drag, and now the forces are no longer balanced, so you're going to get a change in speed, in this case a deceleration, a negative acceleration, and it's going to change. But then as the speed decreases, then the air resistance, the drag, is also going to decrease until the drag also decreases, until eventually you're going to get, and so that then your two opposing forces, right, the weight and the drag, are going to again even out, and you will get a new terminal velocity, a new constant velocity. Right. So the idea is that you need to think about what are the unbalanced forces acting here. All right. And you can say that at the beginning, for example, they're extremely unbalanced, but then as the speed gets faster, then they get closer to each other. So here, for example, they haven't quite balanced out, but certainly the drag is much larger than it was down here, and so you get a slower acceleration. So the amount of drag you have plays into the amount of acceleration you get. And again, that is due to our favorite equation in this topic, which is this, right? So if the unbalanced force is large, That is, it is at the beginning, you're going to get a very high acceleration, whereas here, the force may be only, say, 10 newtons or something, and so the acceleration is going to be quite slow. So that's what it means, and this is an extremely common question, it can be anywhere from 3 to 5 points.